Okay, everyone, this is a little bit of an insight into how to do the deconstruct and design investigation. So the performance standard that I'm most worried about or most focused on is this one up here: critically deconstructs a problem and designs a logical, coherent and detailed physics investigation. When you are critically deconstructing, you are critiquing it. All right, so you're not just brainstorming. So brainstorming might be breaking down the problem, brainstorming it. Critically deconstructing is talking about it using evidence. So is it good? Is it bad? That's critiquing things. Designing a logical, coherent and detailed investigation. Logical would be, does this investigation actually give me data so that I can answer the question that I'm posing? Coherent, am I able to actually make sense of it? Does the investigation make sense? And is it detailed? So could someone actually pick this up, maybe a year 10 or 11 kid, and run through your experiment and actually carry it out? So these are performance standards that are basically unique for the Decon and design. The other aspect that we can do is look at demonstrating deep and broad knowledge and understanding of a range of physics concepts. So when you're doing the brainstorming, when you're doing the critical deconstruction, you are able to show your depth and breadth of knowledge of 2/3, maybe 3/4 of the entire course, which is really cool. Applies physics concepts highly effectively in new and familiar contexts. So instead of doing projectile motion in terms of kicking a football, shooting a netball, whatever it is, we've got a brand new context that we can use. All of the other stuff is pretty generic to other folio tasks. So now what I'm going to do is scroll down to where this student has actually started presenting. So the first little bit here, I'll zoom out a tiny bit so we can see the whole thing. What he is doing is, I guess, identifying the problem. So a startup company is designing drones to deliver small packages within short distances. To increase the efficiency of the delivery system, could look at aero, batteries, communication, material, motors and propellers, blah, blah, blah. The aim to test one factor's impact on the drone's efficiency through a design experiment. So that's what we're looking at. So this student, Ryan, has talked about aerodynamics. He's talked about the batteries on the drone. So capacity, how much runtime you're going to get, how efficient are they? So good tech, bad tech, good wiring, bad wiring, the number of batteries, their weight, how to control and communicate with the thing, materials, and then down here we've got, the motors on the drone, how big, how many, how strong are the magnets, so how good are the quality of them, and then some of the propellers, so what are they made of? Heavier ones are going to weigh more, so they've got to generate more lift to lift themselves. Also how big they are, what the pitch of them is, so are they a shallow angle? So I'm not sure if, maybe it will. So if we're looking at the pitch, so that is how steep the angle of attack of the blade is. So this one here might generate more lift, but it's going to have way more drag. This one here, not going to generate as much lift, but it's going to create less drag. All right, so one of these two is going to be optimum depending on what you want. The number of propellers and so on and so on and so on. So you can see what this student has done is gone through and talked about each of those aspects that you could break down in context. The number of motors would theoretically increase the stability and load-bearing potential of the drone. This is because each motor should produce the same amount of thrust. So he's actually critiqued it a little bit. If we go down a little bit further, material, he's talking centrifugal acceleration, centripetal forces, talking about tangential speed of the tip of the blade, talking about period of rotation, talking about proportionality, and then down the bottom here we get to the whole point of this thing, picking one of these solutions for the problem. This experiment will require only one factor to investigate. I could do this, I could do this, I could do this. However, I'm going to do this one. Therefore, the easiest and most practical factor to investigate is the propeller size and the amount of thrust each size produces. And then he's justified why he's done it. So he's not just gone through and said, I could, here's an aspect that's related to drones and here's, aerodynamics and batteries and blah, blah, blah. Relating them to the subject outline as much as he could. He's then gone and said, I could do an experiment on this, I could do an experiment on this, however, this would require blah, 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 this can be costly, etc., so I'm not going to do it. Here's the one I'm going to do, and here's why. Then he's gone through and designed. So he's got a hypothesis, he's got some variables, he's got some controlled variables and why or how they're going to be controlled. Then he's gone through, here's the equipment, here's my procedure, and you'll notice this is to ensure blah, 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 blah. Tearing the scales is important as it allows for such and such. This provides blah, 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 blah. This is to ensure, etc., etc., etc. So what he's doing is not just saying do this, do this, do this, do this for this reason, do this for this reason, do this for this reason. So he's explaining what's going on. So that's the detail. When you are critically deconstructing, you are deconstructing, and then you are talking about that deconstruction, talking about those factors. When you're getting down to here, this is really good evidence of being critical with the deconstruction. And then when you're getting into the logical, coherent, and detailed investigation, this is logical because it's going to make sense. Changing the size of the propellers, like the length of the propellers, is going to change the amount of like thrust or lift they're going to produce, which is related to the efficiency of the thing. So it is logical. It's going to answer the question. Coherent, yeah, you can absolutely follow this through. Detailed, hell yeah, because he's even got, labeled diagram of the setup. Do this for the procedure is really well justified down to here. Then he's gone and given you, a possible table of results that you could take. And then he's given the expected results, where he's done a bit of background research and said, I reckon this is probably going to be what's happening. So when a student goes through and does their 3 trials at each length and takes the average, so we're reducing the effect of random error, draw their graph, here's the relationship we're expecting. Then he's also gone on, here's some of the limitations that this experiment has in it, all right? So it's not just a brainstorm, it's a brainstorm with a purpose. It's a chance for you to show off exactly how much you know about the course. Okay, so what I've done now is switched into another student's version of the exact same thing. So you can see this student has decided to get all artsy or a little bit more artistic, and what they've done is, this is literally on an A3 bit of paper, because you get 4 A4 pages or equivalent, so you get the 2 A3 pages. So what this student has done is gone, all right, I could have brushed motors or brushless motors. I could look at Bluetooth and radio waves and Wi-Fi and GPS and how these things communicate. So in the middle is drone delivery, and then here's their motors and size and antenna and batteries and propellers and the shape of it, and then broken all these bits down into more bits and then talked about them in a little bit of detail around the outside here. All right, so this student has done it in a very different way to the table in the Word document that you just saw, but this is really easy to see where their understanding of a huge amount of the course comes from, and the amount of things that this student is able to talk about with a fair bit of clarity behind them. All right, so depth and breadth of understanding of a range of physics concepts, it's ticking all of those boxes here. So depth of understanding, that's all this detail. The breadth of understanding is how many different times they've taken the opportunity to use all of that detail. I can't remember what I've done there. Oh, there we go. Deconstruct is incredibly thorough, with each element broken down into what it is, how it matters, what could be changed, and a possible reason for how it could be implemented into a prac. Each element is critiqued and shows an excellent level of understanding of 2/3 of the subject outline. And it's pretty obvious that it does. So there's a lot of equations here. There's a lot of the subject outline just in this one document. And we are back with the exact same student. This is their design of their investigation. So again, hand-drawn, expected, relationship between the 2 variables. Here's some, a rough, here's what you could do in terms of a table of data. Here's the experimental, setup, what it should look like, list of equipment, aim, hypothesis, safety stuff, and then independent, dependent, and then where are we? Here's the method up here in that corner. There's my feedback from it. You can pause it if you want to read that. But you can see they've justified everything. All right, so here's where they've, options to explore. They've gone picture of propellers, motor, brushed versus brushless, and length of the propellers. So option 1, option 2, here's what it could do, here's how it could be done. Here's another option, here's what it could be done, and here's another option, here's what could be done. So what they've done is said, could do this, but I'm not gonna, could do this, but I'm also not gonna, but I'm gonna do this one, all right? And then they've expanded on how to do the experiment, The fact that it's handwritten and you've got to zoom in a bit to read it is totally irrelevant. We're not looking for pretty, we're not looking for fancy. What we're looking for is, can you read it? Does it make sense? We call these distractors. So if a student's handwriting is messy, doesn't take away from what they've written, okay? So with the Decon, it is your chance to show off just how much you know and about a whole range of the course, but also how much you know about how to actually run through the scientific process.